Hi everyone, welcome to another video tutorial for mathematics methods. For today, we will be looking at one of the questions from Wace 2016, and specifically, we will be exploring the concepts of optimization and trigonometry. Question number 8 of Wace 2016 combined two of the most challenging concepts in our syllabus. First, they had optimization, and combined with trigonometry, they did form one of the more tougher questions for that year. Okay, while it can look very challenging and maybe you are panicking right now, maybe we can just take a look at the question part by part and see how we can solve it. Okay, first off, this is question number 8. Pause the video to read the question. Also, observe that the triangle is an isosceles. For part A, and this is a very common question, the candidates were required to find and prove the area of the triangle according to this equation. Let's take a look at how we can actually zoom in into the triangle to get the area. Okay, the area of the triangle can be obtained by using this formula shown on the slide. We then have to find the equations for height and base. But how can we link the angle with the radius? To attempt that, let's try and simplify further the diagram. Okay, zoom in on that triangle which is in yellow, the ROZ triangle. I will give you a hint. This is a right-sided triangle. Okay, so now let's try and get the equation for the base. First off, we can link the base of RZ with this equation, sine theta equals to RZ over R. Then we rearrange to obtain RZ, which is R sine theta. And finally, we get the full length of the base, which is R cubed. We just multiply it by 2, so we will get 2R sine theta. With the base done, let's get the height. The height can be defined with this equation, which is h equals to OZ plus R. With that, we want to find OZ. So cos theta equals to OZ over R. So we rearrange to get OZ equals to R cos theta. And finally, the height is just equals to R cos theta plus R. Now with the height and the base, we can finally finish the question. Okay, let's take a look at the equation for the triangle, which is half multiplied by height multiplied by base. And then we substitute height and base to obtain this equation. And finally, by simplifying the equation, we obtain the answer. Now, maybe you want to take a break before we proceed to part B. In part B of the question, candidates were required to maximize the area. And to add on a little bit to the complexity of the question, students were also required to use this hint. You may pause the video to read question B. For this part, it's going to be a little bit long and it requires you to do some differentiation. Now remember, this is a calculator-free paper, so no calculators to help you. First off, let's get the equation for the area, which was shown in part A. We are going to differentiate this, and remember that to maximize it, we will equate the first derivative to 0. After we differentiate it, we are going to obtain this equation, and remember that for R square, it is a constant. So we will treat it as a constant. After the first differentiation, we are going to simplify the equation, and over here we observe that we have sine square. When we have sine square here, look back to the hint over here. Now we are going to substitute the sine square theta with the hint, and then we are going to simplify the equation and also do a little bit of factorization. Now that wasn't so long, wasn't it? Okay, now with this equation in hand, we just have to remember to equate it to 0. Okay, now since r squared is a constant, we can actually get this equation equals to 0. So now we only need to focus on these components. From here, we know that cos theta will be equals to half and cos theta equals to -1. From here, a student taking the final exam is expected to know how to obtain the theta of pi over 3 and also theta equals to pi. But over here we have a choice to make. Most of the times, questions only have one answer. For this question, let's go back again to the diagram. Over here, focus on the theta. Did you notice something? You must come to the conclusion that theta can only be bigger than 0 and smaller than pi. This means that the angle can only be bigger than 0 degrees and smaller than 180 degrees. Therefore, we can now exclude theta equals to pi since pi radians is equals to 180 degrees. And finally, taking theta equals to pi over 3, we insert that value into our equation, and finally we can get the answer. Okay, maybe you will be wondering, how do we get the values of sine pi over 3 and also cos pi over 3? I'm going to give you a little hint here. Going to your calculator free paper, a candidate must remember certain key values, and this can be illustrated by using this 30 degrees, 60 degrees, and 90 degrees triangle. And with that, we have finished question 8 of 2016. Alright, and that's the end of our video tutorial for today. All the best for your exams, and we will see you next time.